All right, we're going to go through example B of example 1, or problem B of example 1, from 13.6 on the law of cosines. For this problem, we have all three side lengths, but we don't have any angles. Now, last time we used the law of cosines, we had two sides and the angle in between. And we were able to plug that angle in into our law of cosines. But with just three sides, we can't really use the same law of cosines as we had before. So let's plug in what we have. And what we're going to try and solve for first is this largest angle. You always want to solve for the largest angle whenever you have just three sides. I won't get too far into it right now, but basically it has to do with those ambiguous cases that we skipped over from last section. So to save yourself a lot of trouble, just always find the largest angle, and you know it's the largest angle because it's across from the largest side. So we're going to try and solve for angle C first. The law of cosines has an angle at the end, and that angle matches up to the side that you're solving for. And what I mean by that is if you write the law of cosines for side C, you would have c squared equals a squared plus b squared minus 2 times a times b times cosine of angle C, right? So you have C here on the left, C here on the right. You have the side length, and then you have the angle. So when we're trying to solve for angle C, we want to set up our equation with side C out in front here. So let's go with 12 squared equals a squared, so 10.5 squared plus b squared, 6.3 squared, minus 2 times 10.5 times 6.3 times cosine, and this is what we don't know, angle C. So we leave that as our unknown quantity. All right, now we need to rearrange this equation for angle C. What I love, if you follow along with the book example, they go from this to having cosine C by itself with, they skip over a lot of steps, and it's not necessarily something that, needs a ton of explanation, but you want to make sure you do everything in the right order here. So what I would do is subtract my 10.5 squared and my 6.3 squared to the other side to cancel them out here. And then I'm going to have to divide by all of this right here. So right now what I have is 12 squared minus 10.5 squared minus 6.3 squared equals negative 2 10.5 6.3 cosine C. So I'm going to divide by all of this. These four things over here are being multiplied, so I can divide by negative 2 times 10.5 times 6.3 so that I have this cosine C all by itself. So now I've got 12 squared minus 10.5 squared minus 6.3 squared. And at any point in this, if you want to start, simplifying and typing some stuff in your calculator, you can. You don't have to write out everything as being separate numbers here like I am. We're going to put negative 2, parentheses 10.5, parentheses 6.3 equals cosine of C. And let's go ahead and go to the calculator. Now, it might be helpful here to do this in separate entries. Do the numerator first, then the denominator, and divide. If you want to type it in all at once, you can. I think that's what I'm going to do. You just have to make sure you have parentheses around the numerator and then also the denominator. So I'm going to go parentheses 12 squared minus 10.5 squared minus 6.3 squared, close parentheses, there's my numerator, divided by, and then I'm going to do parentheses around negative 2, 10.5, 6.3, close parentheses for 6.3, and then close my parentheses for my denominator. Make sure you can see that without the glare. So that should give us the answer on the left side. It's going to be a decimal. If it's not a decimal, then there was a mistake somewhere. Our next step is to get rid of this cosine, and we do that by using cosine inverse. Cosine inverse only works if you're plugging in a decimal, something less than 1. So if it doesn't come up with that decimal, then there was a calculation error somewhere. Maybe you missed a negative or a squared in the calculator. So just check for that. So that's going to give us 0.04 with some other stuff. For right now, I'm going to write 0.04 equals cosine C. And now we are taking cosine inverse of the left and the right to get C by itself. So angle C is going to equal cosine inverse of that 0.04 that we still have on our calculator. And we again want to make sure we are in degrees. Looks good. So let's go cosine inverse. Hit second and then cosine to get cosine inverse. And then hit second and then the negative button to bring up your last answer. And we get 87.4. So that is our angle C, 87.4 degrees. So we have our first angle. We still have all three sides. And now that we have one of the angles, we also have its corresponding side here of 12. Now we can use law of sines. Let's solve for angle A using law of sines. So let's go sine of angle A over the side A, 10.5, equals sine of angle C that we know is 87.4 over 12. All right, we'll do some rearranging here. We get sine of A equals 10.5 times sine of 87.4 over 12. And let's go ahead and actually get rid of this sine at the same time. So we just have to do one calculator entry here. So I'm going to go sine inverse, and then I'm going to type in all of this. Sine inverse to cancel out the sine on the left, so we just have angle A. So sine inverse, and now we have 10.5. Let's do some parentheses here. 10.5 times sine of 87.4. There's our numerator, divided by 12. Close the parentheses for the sine inverse. And we get 60.93. And that's going to stay as 60.9 when we are rounding to the 10th. So 60.9 degrees. Just one more angle to find. Since we have two angles here, let's do some subtraction. This time I'll just go ahead and do 180 minus 87.4 minus 60.9. 180 minus 87.4 minus 60.9. Now we've done a lot of rounding throughout this process. Both of these angles have been rounded, and that 60.9 is actually based on a process that used a rounded answer. So that's basically all to say that your final answer here, if you add it to your three angles, they should equal 180 degrees, but you might be off by, let's say, 0.1. I think right now if I add these all up, I get 180.1 degrees. That's just from rounding error, and that's okay. That's going to happen whenever you have problems like this. So that's our angle B, 31.7 degrees. We started with all three sides, so that was side, 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 and now we have all three angles. There you go.